In this video, I am going to discuss detailed solutions of all those questions those are appeared in GATE 2008 pertaining to the subject communications. You will find these question numbers on GATE 2008 paper which are from communications. I will discuss solution detail one by one. First question is question number 20. In this question, consider the amplitude modulated signal that is given AC cos omega ct plus 2 cos omega mt cos omega ct. For demodulating the signal using envelope detector, the minimum value of AC that is required we will find out. So the amplitude modulated signal is given AC cos omega ct plus 2 cos omega mt cos omega ct. If we represent it in standard form, then we will take this AC common, then we will have the expression as this, that is AC whole into 1 plus 2 by AC cos omega mt whole into cos omega ct. Now what is the modulation index? Modulation index is nothing but 2 by AC. So the modulation index AM equal to 2 by AC. Now for the envelope detector, the minimum condition is that the modulation should not be over modulated. So to avoid the over modulation, the condition should be AM should be less than or equal to 1. So if we substitute 2 by AC here, then 2 by AC should be less than equal to 1, then AC should be greater than equal to 2. The minimum value of AC will be when AC is equal to 2. So the minimum value of AC is required to be of 2 units. And in the question, it is asked the minimum value of AC that is required for the envelope detection. So the minimum value of AC required for the demodulation is 2. Hence, A is the correct answer for question number 20. Next question is question number 24. In this question, the PDF, that is the probability density function of a random variable, is shown below. That is the plot of PDF versus x-axis is given. We have to find out what is the CDF, that is the cumulative distribution function. We will see first few key points about the cumulative distribution function. The CDF, that is the cumulative distribution function, is non-negative. For any value of x, the CDF is always positive or equal to 0, but it cannot be negative. So that is the first feature of CDF. And CDF at minus infinity is always 0, and CDF at plus infinity is equal to 1. And CDF at plus infinity is nothing but the area under the curve of PDF will give the CDF final value, that is CDF plus infinity. So you can say the integration of minus infinity to infinity of the PDF curve in respect of x-axis, that is x here, so dx, that value will give 1. That you can easily cross check here. The area is nothing but the area of the triangle, that is the base is here 2 units and the height is 1 unit. So the area is 1, which is satisfying. So now if we see the CDF is non-negative, means there won't be any negative value of CDF. If you see in option D, there is negative value of CDF. So option D is easily eliminated. Next, what is CDF? CDF is nothing but integration of PDF in respect of dx, and the limit is from minus infinity to x. So what is the PDF? We'll write this PDF in mathematical expression. Basically, if you see, the PDF has 2 parts, that is when x is less than 0 and when x is greater than 0. When x is lying between minus 1 to 0, the PDF function is simply x plus 1, okay, x plus 1, and when x is less than minus 1, this is already 0, so we have not mentioned that part. Similarly, during the positive part, that is when x is lying between 0 to 1, the PDF is nothing but minus x plus 1. When x is lying between 0 to 1 and from 1 to infinity, the value is simply 0. So we have not mentioned here. Next, what is the CDF? CDF is nothing but integration of PDF and the limit is from minus infinity to x. So the CDF will have two cases here because we have two limits. When the x is lying between minus 1 to 0, that is x is negative, then we have the CDF as x plus 1, that is PDF integration x plus 1 dx, and the limit is from minus infinity to x. Because from minus infinity to minus 1 there is no value, that is 0. So that integration will always be 0. So we have not mentioned here that limit. So simply the limit is from minus 1 to x, x plus 1 dx when x is lying between minus 1 to 0. And when x is positive, that is x is lying between 0 to 1, then the integration will have two parts. First part will be integration of this one and second part will be integration of this one. So the first part will be integration of x plus 1, the limit is from minus 1 to 0, and the second part is minus x plus 1 integration with respect to dx, and the limit will be set from 0 to x. Because the CDF integration will always start from minus infinity, so whether x is negative or x is positive, accordingly the integration will be done. Now let us focus on the CDF. When the x is lying between minus 1 to 0, that is this integration, we will integrate this one, we can easily integrate this one. If we integrate, then we will have CDF of x is nothing but x square by 2, and this will be plus x, limit will be from minus 1 to x, minus 1 to x. So if we substitute this and we will simplify, then we will have a function of x, that is x square by 2 plus x plus 1 by 2 when x is lying between minus 1 to 0. Next, when x is positive, that is x is lying between 0 to 1, that is when x is lying between 0 to 1, then we will have these two factors that will be integrated. So we have CDF of x is equal to x square by 2 plus x, limit is minus 1 to 0, plus minus x square by 2 plus x, limit is 0 to x. After further simplification, we will get the CDF of x when x is positive, that is lying between 0 to 1, we will have this function, that is function of x, that is 1 by 2 minus x square by 2 plus x. So we got two part of the CDF, that is CDF when x is lying between minus 1 to 0 and CDF when x is lying between 0 to 1. We have two functions. Now let us take CDF at different point. First, let us check when the value is minus 1, then what is the value of CDF. When the value is minus 1, that is x is minus 1, we will look for CDF of this value, because when x is lying between minus 1 to 0, this CDF will come into picture. So we will substitute minus 1 here to get the value of CDF at minus 1. So the value of CDF minus 1, if we substitute minus 1 here, because this will become plus anyway, so 1 by 2 plus 1 by 2 is simply 1, and this is minus 1, so total value will be 0. So CDF of minus 1 is simply 0. Okay, if you see in the options at minus 1, it is 0. Next, what is the CDF at 0? CDF at 0, we can put x equal to 0 either in this expression or in this expression, because 0 is included in both the limit. So CDF of 0, if we put here or here, then we will get simply 0.5 or 1 by 2. This condition is also satisfied by all the three options A, B and C. D option is already eliminated. If we see closely option A, C, B, the slope in all the questions are different. So we will check for the slope of the CDF to match with the option. Then we see the nature of the curve. How to find out the nature of the curve? First, let us find out the slope. When x is negative, then the slope will be simply, if we differentiate this with respect to x, we will get simply x plus 1. Similarly, we can get the slope when x is positive. By differentiating this factor, we will get 1 minus x. Now we have to find out the nature of the curve, how it will be. Okay, for that I have taken one snap from my notebook where it is mentioned about the monotonic function, that is when it is strictly increasing, and when it is strictly decreasing. Let us focus on strictly increasing case. The first derivative should be always positive for strictly increasing case. If we see whether this curve or this curve, that is the function is always increasing when the first derivative is positive. Similarly, when the first derivative is negative, then the curve will be simply decreasing function. Now, for the nature of the curve, for strictly increasing case, when the double derivative is also positive, then it will be concave up. That is, both the first derivative and second derivative are positive, then the curve will be like this, or it will be concave up. In the second case, when the second derivative is negative, that is first derivative is positive and second derivative is negative, then the curve will be concave down. Although it is increasing, but it will be concave down. Similarly, coming to strictly decreasing case, when the second derivative is positive, then it will be concave up like this, and when the second derivative is negative, then the curve will be concave down like this. We should always know that the CDF function is a non-decreasing function. So we'll concentrate upon strictly increasing case, that is these two cases. So we'll try to find out the first derivative of CDF, then the second derivative of CDF, then we'll check for these conditions. Accordingly, we can conclude about the nature of the curve. So we have already found out the first derivative. Okay, first derivative is nothing but the slope of the curve. So if we see, when x is negative, CDF dash x equal to x plus 1. Here x is lying between -1 to 0. If we substitute here any value lying between -1 to 0, then this value is always positive. So this value is always positive. Similarly, coming to this case, when x is lying between 0 to 1, this value is also will be always positive. Okay, so both the value will be positive. We have left the boundary condition here, that is when x is equal to 1, it will become 0, and here when x equal to -1, this will be equal to 0. So first derivative of both the curve, that is when x is greater than 0, x is less than 0, is always positive, or we can say non-negative. Now let us try to find out the double derivative to find out the nature of the curve. If we take the double derivative when x is negative, then we will have simply 1, that is this is always positive. Coming to this case, if we take the double derivative, we will get simply -1, and this is always negative. This is always negative because -1 is always less than 0. Now as first derivative is positive as well as the second derivative is positive when x is negative, so the nature of the curve will be concave up. Coming to this case, first derivative is positive but the second derivative is negative, so the nature of the curve during positive region of x is concave down. Okay, because when both the first derivative second derivative is positive, the curve is concave up, and when the first derivative is positive but the second derivative is negative, then the nature of the curve will be concave down. So when x is negative, the curve will be looking like this, and when x is positive, the curve will be looking like this. Now if we see in the option during the negative region, this is concave up, that is matching, the nature of the shape is matching with our derived result, that is concave up, and during positive region of x, the curve is concave down. Whereas in this case, during negative region, it is concave down, and during positive region, it is concave up. So this is reverse of our derived result, and this is exactly matching with our desired result. And here we can easily eliminate option B because it has a constant slope, that is we can easily find out the slope, that is height is 1 and this length is 2, so 1 by 2, the slope is 0.5, always fixed. But here we have already found out the slope is a function of x, that is the slope is varying in nature. Here is also the slope is varying in nature, so option B is also not correct. Hence, with our derived result, option A is matching. So Option A is the correct answer for question number 24. Next question is question number 29. In this question, the probability density function is given as m exponential minus 2x modulus plus n exponential minus 3x modulus for a real random variable x is given, and it is also given that m and n both are positive real number. Then we have to find out the equation related to m and n. Among the options, we have to see which one is correct. Simply, as the PDF is given, as I have said earlier, if we integrate this probability density function over the interval from minus infinity to infinity, that is the area under the curve, that will be always equal to 1. So, if we integrate, that is the PDF in respect of dx from minus infinity to infinity, we will get 1. So, we will try to integrate this factor. Hence, we have substituted this value here. As the modulus function is there, so this is an even function. Simply, here we can apply the integration property. That is, the integration interval will become 0 to infinity, and 2 times the integration will happen. So, applying the property of integration, the limit is changed to 0 to infinity 2 times, and the positive side is nothing but minus 2x minus 3x is taken. That will be integrated in respect of dx, and that value will be equal to 1. So, if we integrate this and we will put the limit, then we can easily get this expression, that is 2 times m by 2 plus n by 3 equal to 1. If we further simplify, we will get m 2 by 3n equal to 1. So, if we see, option A is matching with our desired result. Hence, option A is the correct answer for question number 29. Next question is question number 36. In this question, a memoryless source emits n symbol each with a probability p is given. The entropy of the source as a function of n increases as log n, decreases as log 1 by n, increases as n, increases as n log n. That we have to see among the options which one is matching. We know the entropy formula, that is H equal to summation of minus pi log pi, that is pi is the probability of ith symbol. In the question, it is given that each of the n symbols are having equal probability. So we can simply write the probability p1 equal to p2 equal to up to pn, that is up to nth symbol, each having same probability, that is 1 by n. If we take care of this negative, then we can simply write as this pi as 1 by pi, and negative is taken care of. Now if we substitute this 1 by n everywhere, then we will get this expression, that is 1 by n log n plus 1 by n log n, and this will be going on up to the nth value, because total number of symbols are n symbols. So each are having equal value of 1 by n log n. Summation will happen. So this will be simply nth time of 1 by n log n. So n will be cancelled, which will become equal to log n. So the entropy is equal to log n. Now if we check with the options, the entropy will definitely increase as log n, and in other options expressions are different. So option A is matching with our result. Hence, A is the correct answer for question number 36. Next question is question number 64. In the design of a single mode step index optical fiber close to upper cutoff, the single mode operation is not preserved if the radius as well as operating wavelengths are half, the radius as well as operating wavelengths are doubled, radius is half, operating wavelength is doubled, radius is doubled, and operating wavelength is half. We have to see in which case the single mode operation is not preserved. What we know is the normalized frequency, that is f equal to 2 pi a by lambda into numerical aperture for an optical fiber. where A is the radius of the core and numerical aperture is usually fixed because of the refractive index of the core and cladding. So F we can say is a function of radius and wavelength. Now for single mode operation, the frequency should be such that it should be less than equal to 2.405 Hz. Okay, so the frequency of operation should be always lying in the region where it is always less than 2.405, or we can say the upper cutoff frequency, that is Fc equal to 2.405. And the single mode to be preserved, the operating frequency should be such that it should be less than equal to the cutoff frequency. So we will check among the options in which case this condition is not matching, because if this condition is not matching, then the single mode operation is not preserved. As I have said earlier, the frequency is a function of radius and wavelength, so we can say frequency is proportional to radius by wavelength. Now let us check different option. In the first option, the radius as well as operating wavelengths are halved, that is radius is halved, operating wavelength is halved. That means their ratio will remain intact. So the operating frequency will be same as the cutoff frequency. So the single mode operation is preserved in this case, as the frequency of operation is equal to the cutoff frequency. Coming to the second option, in the second option, radius as well as operating wavelength both are doubled, that is radius is doubled, operating wavelength is also doubled. That means in this case also their ratio will remain as same or intact. Hence the operating frequency will be same as the cutoff frequency. Hence the single mode operation is also preserved in this case. Coming to the option C. In option C, radius is halved and operating wavelength is doubled. That is radius is halved, operating wavelength is doubled. That is we have a factor of 1/4, that is the operating frequency is equal to the cutoff frequency divided by 4. That means this frequency is definitely less than the cutoff frequency. So the operating frequency is less than the cutoff frequency, hence the single mode operation is preserved in this case also. Now coming to the option D. In option D, the radius is doubled and operating wavelength is halved. Radius is doubled, operating wavelength is halved. That is we have a multiplied factor of 4. So in this case the operating frequency is 4 times the cutoff frequency. That is the operating frequency is higher than the cutoff frequency. So this mode won't be propagated in the single mode optical fiber. Hence for this frequency the single mode operation is not preserved. So option D is the correct answer for question number 64. Solution to rest of the questions will be discussed in part 2 of this year video. You may click the link mentioned below this video for part 2 solutions. Thanks for watching. Keep watching and keep learning.